We'll solve using the corner point method. As before, we will graph this system of equations. Remember, this guy says stay in quadrant 1. Q, the first inequality, x-intercept of 2, y-intercept of 8. Let me count that again. 1, 2, 3, 4, 5, 6, 7. See, that's why you go to school to count correctly. All right, 1, 2, 3, 4, 5, 6, 7, 8. All right, solid. And shading above, because 0, 0, for example, makes it false. Staying in the first quadrant. Second one, I'll do in green, x-intercept of 4, y-intercept of 4. Solid line. Label. And shade. This would also be above. Please do not assume that if the inequality is greater than or equal to 0, it always means above. That is not true. You need to do a test point like we've done before. And the last one, I'll do an, I don't know. I don't know if I like this color. Alright, we're doing it. Oh, I didn't mark the color. So that'd be an x-intercept of 8 and a y-intercept of 1.6. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. 1.6. All right there. Solid line. I'll call this color salted caramel. And by the way, never say caramel. Caramel has 2 A's. Caramel is a proper noun. 2x plus 10y equals 16. And shading, this is also above. Because it's about to get pretty messy, notice in all 3 cases we were above all 3 lines, and we are we are in the first quadrant. So what we have there would be your final answer for the feasible region. We have a bunch of corner points. In fact, we have 4 of them. 2 of them are nice. This point here was the y-intercept of the blue line, 0, 8. This point here is the x-intercept of the caramel line, 8, 0. And then we have where blue and green intersect, and we have where caramel and green intersect. Ooh, caramel apple. Because of that, because they're floating out in space there, and again, my graph could be totally wrong in terms of I was off by a smidge. We need to use the calculator to figure out where exactly those points are. So let's pull up the calculator. Boop. I'm going to clear out there. All right. So let's do the intersection of the blue and the green, which would give us this corner point right there. So second matrix, scroll over to edit. I'm going to edit matrix A, again, 2 by 3, 2 rows. 2 equations, 2 variables and a constant, so 3 columns. So the blue line is 4, 1, 8, and the green one is 1, 1, 4. Once you have your equations in there, second quit, second matrix, go back to math, scroll up, you're looking for RREF, and then put in the matrix name. So the blue and the green intersect at, oh my gosh, decimals. Don't freak. Go to math, convert to fraction. The ordered pair, 4/3 8/3. Cute. Now we need the caramel and the green. So wash, rinse, repeat. Second matrix. Edit. Since the green is the 1, 1, 4, and we already have that as the second row, then we can make the 2, 10, 16 the different, or the new first row, I should say. So we have 2, 10, 16 is the caramel, and the 1, 1, 4 is the green. Quit out of there. I'm going to just do second enter a couple times so I don't have to retype all that stuff again. Hit enter. Oh, that's nice. We get 3, 1. Right. So that was step 1. Make a little chart. We'll say x, y. We'll say z is equal to 3x plus 4y. List your corner points in any order. And you can plug them in. There is a way to make your life a little bit easier. I'm just trying to think. Yeah, if we did this as, you could sort of treat this as a matrix multiplication if you wanted to. For instance, if we took, I have to think, and I'm doing this off the cuff, and this is hurting my head. If we made this a, will this be a 4 by 2? So if we literally did 0, 8, 4/3, 8/3, 3, 1, and 8, 0. So that's a 4 by 2. And if we multiplied it by a 2 by 1, namely 3, 4, then what will happen by design is it would create a 4 by 1, which would be these 4 numbers that we need here, 1, 2, 3, 4. So I'm going to do that. I'm going to use the calculator. Why should I evaluate all that stuff? All right. And also another way to make matrices is by using the brackets. So the first bracket says start the matrix. The second bracket says start the row. And then each row gets its own bracket. This is much more fun. I'm having a great time. I mean, it could be the coffee that I had today, but all right. And then that was the first matrix, and then we'll say here the second matrix. Again, great time. Since I'm doing this live, I hope this works. I'm going to say convert to fraction. All right, so we get 32, 44/3, which we see as a decimal there is 14.6 repeating, 13, and 24. We are trying to minimize, which means we want the smallest value, so that would be 13. So 3, 1 would be the optimal solution. And 13 would be the optimal value. All right.